Good morning, students. In the last lecture, we ate our sixth chapter, that is superposition of waves. Today, we are going to start next chapter, which is chapter number 7, wave motion. And today, we are going to see very important topic, very basic topic in this chapter. It is nature of light. What is light? Light behave as a particle as well as light behave as the wave. So today we are going to discuss the basic about this light, that is what is the nature, of the light. First of all, we see in the last year the ray optics, in which the light travel in a straight line and form the virtual image as well as the real image and other phenomena. Today we are going to discuss another branch of the optics which use the wave nature to describe the phenomena of the light, and this nature is called as the wave nature of light. But before that, we need to discuss the particle nature as well. Okay, so what is the particle nature? Who put forward this theory? We are going to discuss in this lecture. Okay, so what is the nature of light? First of all, the light is considered as made up of a small tiny particles. They are called as the corpuscles. What is corpuscles? Corpuscles are the very tiny particles which are emitted by the source of light. When we switch on a light, then there will be a tiny particles come out of the source. These tiny particles are known as the corpuscles, and this theory is first put forward by Descartes, and then Newton bring forward or improve the theory by putting some another phenomena in the theory. So we are going to see what is the corpuscular theory of light. Which is put forward by Newton. And there are some assumptions which are made in this corpuscular theory. We are going to discuss one by one. The first property or the first assumption by Newton is that these corpuscles are the tiny particles. They are hard and elastic. These particles travel in a straight line. These particles or corpuscles, they are travel in a straight line unless an obstacle is come. If obstacle is come before these particles, corpuscle, then they changes their direction. So the first property of this or the first assumption of this corpuscular theory is that these corpuscles, they are hard in nature and elastic. What is elastic? Elastic means the property of the body by which it regains its original dimension after removal of deforming force. So these particles or this corpuscle, they are hard and elastic. They travel in a straight line. They travel in a straight line unless an obstacle come before it. An obstacle is come, then they change their direction. Okay, this is the second assumption. The third assumption is that when we see the different colors of light, red, yellow, green, blue, these colors are arises due to the different size of these corpuscles. So we can say that we get or we see the colors and these colors are due to, colors are due to what? It is due to the size of corpuscles. If the corpuscle is small in size, then the light has different color. If the size is bigger, then the color will change. So, as the size of the particles or the corpuscles change, the color of the light also get changed. Okay, so this is the third assumption. What is the fourth assumption? The fourth assumption says that we get the sensation of light. We get the sensation of light when this particle enter our eyes. Okay, we get the sensation of light when this particles corpuscle enter our eyes. So this is the next assumption. Then after these assumptions, there are some drawbacks in the Newton's corpuscular theory, which state that when we switch on the light, then if there is the emission of corpuscles there from the source of light, then there must be the decrease in the mass of the source, that is mass of the light. Okay, but if we switch on a tube light and it is on for 1 hour, then we cannot observe that is the mass of the tube light goes on decreasing. Okay, so we can say that the mass of the source not decreases, and therefore we can say that there will be no emission of particles from the any source. Okay, then Newton proposed that we get the sensation of light when this corpuscle enter our eyes, as well as the different colors are due to the different size of the corpuscles, but actually the different colors are arises due to the different wavelength. We are going to discuss in the Huygens wave theory of light. So these are some basic assumptions made by Newton in the corpuscular theory, which state that light act as a particle. Okay, but some of the phenomena like reflection, polarization, refraction, these are cannot be explained on the basis of particle nature. To explain such phenomena, we need the wave nature of light. So, there are some drawbacks in the Newton's corpuscular theory, particle theory, and therefore Huygens applied or put forward his theory, which is called as the wave theory of light, in which he stated that light is behaved as a wave. Light is behaved as a wave. Light travel in a form of wave in the same direction, and it get reflected when there is an obstacle come before it. Okay, it also states that the different colors of the light are due to the different wavelength of the wave nature possesses by the light. Okay, then it also states that there will be no emission of particles when we switch on the source of the light. And Newton also proposed that for the propagation of light, there will be a medium, luminiferous ether is required. If there is no medium, there is no propagation of light from one place or one point to another point. But actually, there will be no luminiferous ether present in the universe. So therefore, there will be a drawback in the Huygens theory also, but due to the successive experiments, the wave theory is considered as a successful theory concerning with the light. Okay, so this wave theory of light explains the phenomena like reflection, refraction, diffraction. Such type of phenomena were explained by the wave theory of light. But particle theory, or particle nature of the light, also explains some basic phenomena like photoelectric effect, Compton effect. This effect explained on the basis of the particle nature. So light, it behaves as a particle nature as well as it behave like a wave nature. So in the case of reflection, refraction, polarization, diffraction, it acts as a wave, while in the case of photoelectric effect, Compton effect, it acts as a particle. So it behave like a two nature, so it is called as a dual nature of light, particle nature as well as the wave nature. The branch of physics or the branch of optics which deals or which use the wave phenomena to explain the lights. Okay, to explain the light phenomena we use the wave nature. This type of branch of the optics is called as the wave optics. The branch of the optics in which we use the wave phenomena or wave structure to explain the light phenomena. It is called as the wave optics, and we are going to discuss in this chapter, which is called as the wave optics, we are going to discuss some properties, some basic concepts which are related with the wave nature of the light. This is enough for today. Have a good day. Bye.